Let's consider the atom. The atom can be thought of as consisting of three particles: the proton, which has a plus charge, the neutron, which has a zero charge, and the electron, which has a negative charge. The proton and neutron weigh about the same within three significant figures. So about 1.67 times 10 to the minus 27th kilograms. The electron is much lighter, 9.1 times 10 to the minus 31 kilograms. The proton and neutron are in the nucleus of an atom. So I have protons, neutrons, and they're very dense, tightly packed. The electron exists outside of the atom, outside of the nucleus, and is free to move, but the two are held together by the opposite charge of the electron and proton, forming a Coulombic attraction. North and south poles of a magnet attract each other. The positive and negative charges of the electron and proton attract each other. Now the identity of the atom is given by the number of protons in the nucleus. All hydrogen atoms have one proton. All neon atoms have 10 protons. All carbon atoms have 6 protons, but they can have varying amounts of neutrons. So one example for hydrogen. Hydrogen always has one proton, but you can have one proton and 0 neutrons. You can have one proton and 1 neutron, or you can have one proton and 2 neutrons. This is called the hydrogen atom. This is called the deuterium atom. And the third one is called the tritium atom. They're all hydrogen isotopes. They all have one proton, but they weigh differently because of the number of neutrons. These are called isotopes of each other. So hydrogen has 3 isotopes, depending on the number of neutrons in the nucleus. Now, hydrogen and deuterium are stable, but tritium is radioactive, it's unstable, and it will decay by undergoing a nuclear reaction. Carbon has 2 stable isotopes. Carbon has 6 protons. So you have 6 protons and 6 neutrons for one isotope. This is called the carbon-12 isotope, C12. You'd have 6 protons and 7 neutrons. This is carbon-13 isotope. This number 12 and 13 are obtained by adding the number of protons and neutrons. Carbon has another isotope, the carbon-14 isotope, but it is radioactive, so it is unstable and decays. But if you had 1 gram of carbon-14, it would take 5,700 years for half of it to decay.